Hello. Welcome to our presentation for the design and implementation of a robotic device for medical percussion. Medical percussion is a diagnostic procedure used in clinical examination whereby the chest, back and abdomen are tapped to determine the condition of underlying tissue through the acoustic response. Although percussion is common in medical practice, there is a limited understanding of its dynamics. The goal of this project is to create a robotic system to perform percussion and record and analyse the acoustic response. The human arm is modelled as a two-link system with a compliant wrist joint. Joint torques were introduced by the extension springs. When the first link hits a hard stop, all of the kinetic energy of the body is transferred to the second link, resulting in a tapping on the body by the end effector. A medical student was asked to perform percussion on an EcoFlex silicon phantom, and the percussion force was measured with a load cell. The percussion force ranged between 8 and 10 newtons, the impulse between 0.7 and 0.8 newton-seconds. Different spring constants were evaluated in the simulation to find the right values that translates to force profiles most similar to the medical student's percussion forces. Simulation parameters are used to build the hardware prototype. The robot was additive manufactured using a Prusa Mark III's. The cam is driven by a continuous servo motor, controlled by an Arduino Uno. The frequency of the tapping actions can be changed by controlling the motor speed, and the percussion force of the robot was captured with a load cell. The robot showed comparable force and impulse profiles to the human participant, with better consistency between percussion actions. Future studies will explore variation in the acoustic response of tissue samples with differing pathologies, and the effects of percussion frequency and force in relation to the acoustic feedback. Thank you for listening.